Okay guys, in this video we're really going to be looking at determining, say, the vertex, focus, and directrix of a parabola, but the equation of the parabola is going to be handed to us in what we call general form of a conic section. And so with respect to general form, let's go ahead and revisit what we mean by general form. And one thing I notice about both of these equations being in general form is that they're both equal to 0. And so that's a pretty consistent theme. But we also see this, we see ax squared. So we have an x squared term plus bxy. Funny story, we have an xy term. We say c just because we need another letter, y squared. So there's our y squared term. We need an x to the first term, so we better have a y to the first term. So we'll build in an e, y to the first. And then because we need a constant, we'll put in f. So with respect to the equations that we look at with conic sections right off the bat, we tend to neglect this right off the bat. And what I want to point out is that we just have a string of, I suppose, variables in two types, where one of them might be squared and the other one might not be squared. And so in terms of general form of a parabola, you're going to notice that both of these equations have one variable being squared and the other one not. Our goal is going to be able to rewrite it into what we call standard form. And so revisiting standard form here really quickly, whether you have a vertically or horizontally oriented parabola matters, but we say that vertically oriented axes have an x term that is squared. X minus h squared equals 4p y minus k to the first. But if you're horizontally oriented, we're going to be squaring out the y variable type, and we say this is equal to 4p x minus h. So with respect to these, if we're going to be trying to take something that looks like this in general form and make it look like this, the one characteristic that I want to point out to you is that there is a squared binomial. And whenever we want to have, I guess, an expression that is a squared binomial that starts off with something that's more in general form, we're going to have to rewrite our squared variable type as a perfect square trinomial. And so here's kind of what I want to start with. In other words, complete the square. We want to be able to rewrite a trinomial of this form here such that the c value is equal to half of our middle term squared. That is to say that whatever b is here, if you were to make the c value equal to half the middle term squared, then what happens is this thing magically, it starts to factor into perfect squares of binomials. So this x squared plus bx plus c, I'm actually going to rewrite it as x squared plus bx plus, and we're going to write it this way, we're going to say plus b halves squared. And that is to say that if c actually is indeed equal to half of your middle term squared, then what happens is this thing has to factor into x plus b halves squared. Okay, so that being said, let's take a look at how this might apply. If I had, say, some expression x squared plus 8x plus c, and I said, well, what do I want my c value to be so that I can factor it into a square of a binomial? I would say, first of all, that my c value would have to be half of 8 squared, or in other words, 4 squared, or in other words, 16. But that is to say that if this was x squared plus 8x plus 16 right here, if that were a 16, then not only would this factor, but it would have to factor into x plus half of 8 squared, or x plus 4 squared. And the reason why is because when you think about this here, this is something that would not only have x plus 4 as one of its factors, but x plus 4 as its second factor as well. In other words, we could just say it's x plus 4 squared. So our primary goal is going to be, at least with the variable that is of the squared type, to rewrite it so that its constant is equal to half the middle term squared, so that we can rewrite it as a square of a binomial. Because if we can write it as a square of a binomial, then we'll be further along towards this standard form of an equation of a parabola. Okay, so let's consider number 20 here. The very first thing that I want you to consider is this, that it is in general form and not in standard form. So we're going to rewrite it into standard form, which means we're going to take the squared variable type, which I've identified clearly here as just the x variable type. We're going to keep anybody that has an x on the left-hand side of this equation, and everybody else has just got to leave. So in terms of what we have here, we'd have x squared minus 2x, and this would be equal to minus 8y minus 9 here if we were to transplant these two terms over to the right side. So the first thing I want you to check for me is this. When we complete the square, we are looking at something that is of the form x squared plus bx. And that is to say that there shouldn't be a constant on the left. And the other thing that's important here is that your leading coefficient on your x squared has to be a 1. So because it is already this way, what we're going to do is we're going to make room, or at least leave a place here, to go ahead and put in a constant that is equal to half the middle term squared. In other words, to rewrite it so that it is on purpose a perfect square trinomial. So the real question is, well, what would I want to have here? Well, it'd have to be half of I'll even write it out here, half of negative 2 squared, which is really negative 1 squared, which is 1. So I want there to be a 1 here, but keeping in mind that this is an equation, what I do to one side I have to do to the other side. So now the left side, let's talk about it. The very first thing I want you to acknowledge is that this is now a perfect square trinomial. That is, it is in this form. And so because it is, we can go ahead and factor the left-hand side, which is really, you guys, the idea. And so what would I put in here? Well, when it factors into a square of a binomial, it's always half the middle term that is the value that goes in here. So a couple ways you can think about this. This was the term that or the value that I had right here that I had squared to get this last number in the first place. Or you could just say what's half my middle term. And so in this case, it is important that half of negative 2 is negative 1. That's going to affect our h value. On the right side though, combining like terms here, we get negative 8y, and it looks like we get minus 8. And so the thing I want you to get excited about is the left-hand side of this, you guys, looks like standard form now. It looks like x minus h squared. The only thing is, does the right-hand side look as I need it to look? And so the thing I want to point out here is that in standard form, inside these parentheses on the right-hand side, the coefficients of y and x that you see here respectively are 1. And that is to say that because this y has a coefficient other than 1, then what we have to do is factor out whatever that is. Even if it doesn't share a factor with this number right here, we have to factor out this first term. And so what it's going to look like in the end is x minus 1 squared on the left, but if I factor out the negative 8, I get left with this y plus 1 left here. And I'm going to throw a big fat box around this because this is going to help us determine all of our values up here. And so we don't roll without a picture. So let's go ahead and start with this. This has a vertex that is at h and k. So h is positive 1, k is negative 1. So we're going to say 1, negative 1. So we'll go right 1 and down 1. Here's our vertex. Other things, well, x term is being squared, so our axis must be vertical. And so what else would you be able to tell me here? Well, let's start with our focus. We know that this right here is 4p. So if 4p is equal to negative 8, then p is negative 2, which means from our vertex, we're going to go down 2 more units here along this axis to get to our focal point, which would have to be at 1 comma negative 3 if this is at 1 comma negative 1 and we've gone down 2. So 1 comma negative 3. At the same time, we went down 2 units to get to the focus from the vertex. So we have to go 2 units up to get to the directrix, and it looks like then it would have to run perpendicular to our axis at a height of 1. And so we say here's, you know what, I'll do this, y equals 1, and say, look, this and this, sorry, I wrote them in the wrong spots, they need to switch around. But the only other thing we'd have to do here is just go ahead and give an idea of what this problem might look like. So again, we're going to complete the square with number 24 here, but this is going to be treated just a little bit differently. Starting with the fact that it looks like y is the squared variable type here. So this term and this term here that have y's, they're going to stay on the left-hand side, whereas we have to move everybody else away from these squared variable types. So if we do that, we get 3y squared minus 6y, but on the right side we'd have minus 24x minus 27. Now, from here, the idea is that we are, again, going to complete the square on the left-hand side with the squared variable type. But the thing I want you to be cautious of is this. The a value, or the leading coefficient, is not yet a 1. And so anytime this happens, we have to have that be the case before we can just put on half the middle term squared. So what we're going to do is we're going to factor that 3 out in front, and we get left with y squared minus, this would be 2y, and this would still be equal to negative 24x minus 27 on the right. Now from here, the thing that I'm going to encourage you to do is, as we did last time, build in a spot to put in that constant that you'd really rather have here. But as we built in that spot last time, you're going to notice that I built in a spot on both sides. So that is to say that in this case, I am going to put plus 3 times this blank. And you'll notice that it is important that I put the 3 here. The reason why is because, well, let's look at this. Half of negative 2 would be negative 1, and negative 1 squared is 1. If I put a 1 here, and I only put a 1 on the right side, this is really 3y squared minus 6y plus 3 when you redistribute your 3. So I'm going to put a 1 here, but I'm also going to make sure that I take it times the same value that I factored out in front of the left. So from here, neat thing is we know the left side factors. And not only does it factor, it factors in the square of a binomial. Not only does it do this, we know that the number that goes in here is half the middle term. And as far as the right side goes, I'm going to go ahead and say 3 times 1 is 3, but combining that like term there, positive 3 with a negative 27, gives us negative 24x minus 24. And so just as we sort of did last time, as we exactly did last time, we're going to do this. We're going to factor out this negative 24 here on the right, which leaves us with x plus 1. Now you would say, I think I'm done. But the thing here is this. This almost looks like standard form, except for what's different. On the left-hand side here, these squared binomials do not have coefficients. And so as a final step, what I am going to do is I'm going to divide both sides by 3, but what I get left with then is y minus 1 squared equals negative 8 x plus 1. And this is fantastic because now I have h bundled with my x, k bundled with my y. This means negative 1, positive 1 is my vertex. Negative 1, positive 1. And it also means that if 4p is equal to negative 8, p is negative 2. So let's start building what I know about this. I know that the vertex is left 1, up 1. I know that because y is being squared, it's a y squared variable type here, my axis runs left and right. And so from my vertex, which is at negative 1, 1, I'm going to go 2 units to the left, since p is negative 2, and I'm going to drop in my focal point, which would be at negative 3, 1. But I'd also have to go 2 units back to the right. I'm trying to bypass that point value there. And we're going to label our directrix at x equals 1. So we have x equals 1, focus must be at negative 3, 1, but it's important we have this in standard form first in order to be able to deduce this. So you're going to have to complete the square at times. Cheers.